What is Monte Carlo tree search for RL, and how does it function? Imagine trying to decide your next move in a complex game or a tricky problem. How do you figure out the best choice when there are so many options? That's where Monte Carlo tree search comes in. It's a smart way for computers to make decisions in complicated situations. Monte Carlo tree search is a method used in reinforcement learning and decision-making tasks. It helps computers explore possible future actions without checking every single one. Instead, it builds a decision tree step by step, focusing on the most promising paths. This makes it easier to find good solutions in large and complex environments. The process has four main steps that repeat over and over. First is selection. Starting from the current situation, the algorithm chooses the next move based on a balance between trying new options and sticking with what seems to work well. It keeps selecting until it reaches a point where it can add new options or reaches the end of a possible sequence. Next is expansion. If the selected point isn't finished and has unexplored options, the algorithm adds new branches to the tree, representing the next possible moves. This helps the system learn more about what could happen next. Then comes simulation, also called rollout. From the new branch, the algorithm makes random or guided guesses about what might happen if it continues down that path. It keeps simulating until it reaches a conclusion or hits a set depth limit. This gives an idea of how good or bad that path might be. The last step is backpropagation. The results from the simulation are sent back up the tree, updating the estimated value of each move along the way. This helps the algorithm remember which paths led to better outcomes and which didn't. By repeating these steps many times, Monte Carlo tree search focuses on the most promising areas of the decision space. It balances exploring new options and exploiting what it already knows works well. This approach is especially useful in games like chess or Go, where the number of possible moves is enormous. In reinforcement learning, Monte Carlo tree search acts as a planning tool. It simulates future scenarios to evaluate actions before actually making a move. It was a key part of systems like AlphaGo, which combined this method with deep learning to master complex games. This algorithm shows how AI can handle decision-making under uncertainty by mixing random sampling with structured search. It also raises questions about how transparent and fair these systems are, especially when used in real-world applications. In summary, Monte Carlo tree search builds a decision tree through repeated simulations, guiding choices by balancing exploration and exploitation. It's a powerful tool for tackling complex problems in artificial intelligence and reinforcement learning.